Good afternoon, students.
Good afternoon, madam.
Right. Um, so the first announcement is this lecture, matrices and vectors lecture, uh, will be held on Tuesday from 1 to 3, right? So there's no change to the lecture time, right? Last week, so I have to shift that because last week actually we started the physical lectures in the faculty for the other batches, right? So you are the most senior batch. For almost all the other senior batches, we have started lectures. So therefore, uh, with the uh, amendment in the schedule, so I shifted this lecture to last Thursday, but that is only for the last week. From this week onwards, again, this lecture will be held on Tuesday from 1 to 3. And also for the programming lecture will be held on Wednesday, 8 to 10. So after you have come to the faculty, right? So then there may be changes in the schedules, but for the online, under the online timetable, so this will be in the same place as you are aware of, right? So tomorrow also you will be having the programming lecture from morning 8 to 10, right? So last week we have started determinant and we have completed determinant part 1. I hope you remember the most important thing that we have learned there is the properties. Actually, I believe that you didn't cover the properties under basic maths. So we covered the properties, determinant properties there last week, right? So as the continuation of the last week, today we are going to continue the determinant part 2. And the lecture notes are uploaded to the LMS. Right. So, so adjoint of a square matrix. So I think you are already aware of this adjoint. Adjoint actually, why we need adjoint? Anyone? So what is the use of adjoint?
You can find the inverse.
Inverse, right? So in order to find the inverse, we need the adjoint, right? So last week, you learn about how to find the minors, how to find the cofactors, and then next come after you find in the cofactor matrix. So next one is adjoint. So if I ask again, what is the difference between the cofactor matrix and the adjoint matrix? What is the difference between the cofactor, the matrix created from the cofactor elements, and the adjoint matrix? Or else how you convert cofactor matrix to adjoint? Anyone? Right. So, but all right. So we see one as the transpose of cofactor of elements. Yes. So, right. So after, so you know that you can remember that in order to uh, calculate the inverse, you need the adjoint. So the next problem, so if you know adjoint is necessary to calculate inverse, so the next question is how you get the adjoint. So how you calculate the adjoint? You know how you calculate minors, then how to convert minors to cofactor elements, and then so how to convert cofactor to adjoint elements. So the thing is what we have done is the transpose. This is very important, students, because most of the students, right? So nearly 50% of students. So when I asked to calculate the inverse, So they find the minors, they find the cofactors. What they are doing is then they straight away divide the cofactor matrix by the determinant. They forgot to get the transpose and convert it to adjoint matrix before dividing it by the determinant. අපි දන්නවා ඉන්වර්ස් එක හොයනකොට adjoint එක determinant එකෙන් බෙදන්න ඕනේ. නමුත් ගොඩක් අයට අමතකයි cofactor matrix එක adjoint කරද්දි transpose කරන්න ඕනේ බව. So therefore it is mandatory, otherwise the answer that you will give me as the inverse is wrong. So it is important. So after you have obtained the cofactor matrix, you need to get the transpose, right? So here, so again, the slide reminds you, so whenever you are provided a matrix, so when you are provided this particular matrix, how you are finding the minors and how you are how to find the cofactors, right? So for example, I think you can remember, so we select a particular element, right? We select a particular element. When we cut that particular element through rows and columns, so the rest ඉතිරි element sticker. So this will be the minor of element A1. Likewise, so almost all the 9 elements. So here this is the dimension of the matrix is 3 by 3. So there are 9 elements. So all 9 elements have their own minors and then the cofactor. Right? So so here you can see the elements are represented in simple lowercase A1, A2, A3, B1, B2, B3, C1, C2, C3, all are in lowercase. So in order to represent the cofactor element of each and every element, we have make a cofactor element capital value indicate. So almost all the cofactor element of each and every 9 element has been indicated in capital letters. Likewise, for simple A1, the minor is B2, B3. Minor is the matrix consisted of B2, B3 and C2, C3. So when you find the determinant of this and then when you consider the cofactor, you will come up with A1. Likewise, all the other 8 elements have been filled in same manner. Right. So then you have the cofactors of elements. Then out of the cofactors, then transpose of the matrix of cofactors. Transpose of the matrix of cofactors is called adjoint. So initially, you can see A1, A2, A3, B1, B2, B3, C1, C2, C3. So when you transpose this, so it will be converted as A1, B1, C1, A2, B2, C2, A3, B3, C3. So finally, this is the adjoint matrix of A. Cofactor element matrix එක අනිවාර්යයෙන්ම transpose කළ යුතුමයි adjoint එක ගන්න. adjoint එක තමයි අපි determinant එකෙන් බෙදලා inverse එක හොයන්නේ. So if this is the case, so then tell me, what is the adjoint of this matrix? Please calculate the adjoint of this matrix. Here again, I'm requesting you and warning you, please don't use calculators, right? So if you used to calculators, then you will be lost when you are coming physically to your final exam. So therefore, please try to do almost all the calculations manually. So then please find the adjoint of this matrix. Those who have finished, you can send me the answer. Okay, so I have received one answer. Small differences between two answers I got. Any more answers? Okay, we'll see. So this is the answer. Most of you have obtained a solution, but in almost all the answers, right? So there are problems with, I mean, pluses and minuses, right? With the this problem with the signs, and there are some problems with the elements, right? So anyway, this is the answer I got, right? Anyway, so it is important, right? So to do the calculations correctly, right? So otherwise, because depending on this adjoint, you are going to calculate the inverse. So finding the adjoint clearly is very important, right? Okay, right. So here, so they have come up with the cofactors of all the 9 elements, and then the cofactor elements have been transposed to find the adjoint. Right. So after learning about the adjoint. So the next step is calculating the inverse. So what is the inverse of a matrix, right? I'm sure again that you have learned in inverse in the basic maths. So actually, what is it? So just like number has a reciprocal, right? So every number has a reciprocal, right? So what is reciprocal, right? Every number, for example, if it is 2, the reciprocal is 1 over 2. If it is 5, it is 1 over 5. If it is 100, the reciprocal is 1 over 100. So likewise, right? So for a number, අපි ගත්තොත් number එකකට තනි ඉලක්කමකට. So we know that matrix is a collection of numbers. But if we consider about one single number, right? One single number. So there we can't. So normally we are not defining something called inverse, but other than that we are defining something called reciprocal, right? So likewise, but when we consider about a matrix, so we can't just consider about reciprocal, but what we consider is the inverse, right? තනි number එකක් අපට 1 8 8 නම් 1 8 8 2 නම් 1 8 2 5 නම් 1 8 5 කිව්වට, so for a matrix we can't just put the whole matrix under 1 divided by that particular matrix. So instead of that we are um, bringing the concept called inverse, right? Inverse. So if A is a matrix given, so the inverse can be indicated as like this, right? So we write A inverse instead of 1 divided by A. So in the matrix under the matrix world, we are not normally writing 1 divided by A. Right? Instead of that, we are writing this. We write A to the power minus 1. A to the power minus, because we don't divide by matrix, right? So usually we don't divide by matrix, and there are the similarities. So this is the notation of a matrix, inverse of a matrix, right? Inverse of a matrix. Right. So the next thing is, when we multiply a number by its reciprocal, we got one, right? We get one, right? We have to see සංඛ්‍යාවක් එයාගේම reciprocal එක. දැන් අපි කිව්වා if it is 8, the reciprocal is 1 over 8. But if we multiply the number with its own reciprocal, the answer we got is 1, right? Number එකක් එයාගේම reciprocal එකෙන් අපි කියනවා නැත්නම් 1 8 සංඛ්‍යාවෙන් වැඩි කරාම අපිට උත්තරේ 1යි. Right. So likewise, so under the matrix world, right, so when we multiply a matrix by its inverse, we get an identity matrix. So you know that. So in the number world, so the meaning of one, the unity can be represented when we come to the matrix world. So it is identity matrix, right? එක කියන එක represent වෙන්නේ matrix ලෝකේ I එමත identity unity matrix එක විදියට. So same thing, that inverse comes first. So it doesn't matter whether A multiplied by 1 over 8 is 1, and also 1 over 8 multiplied by 8 is 1. With the අට වැඩි කිරීම එක අට අට කිව්වා, එක අට වැඩි කිරීම අට කිව්වා, දෙකෙන් වෙන එකයි. And also here, right, A times A inverse is I, and also A inverse times A is equal I. So I think you may have remember. So I'm asking whether matrix multiplication is commutative or not. Whether matrix multiplication is commutative or not. Yes or no? Yes or no? I need the answer. So we have done this property at the very basic lecture. Whether matrix multiplication is commutative or not. Then I'm sure. So you are wondering what do you mean by commutative? Kala commutative. What do you mean by commutative? Right. So yes, the answer is no. What do you mean by commutative? A multiplied by B. Right. A is a matrix, B is a matrix. Right. So always A multiplied B is not always equal as B multiplied by A. Right. So right, for the matrix, this commutative property just not valid. Right. For the matrix, this commutative property we say does not hold, right? So matrix multiplication, not like the just real number multiplication. Matrix multiplication is not commutative, right? But here you will see that A multiplied by A inverse is I, and also A inverse multiplied by A is also I. So this is a special occasion where the matrix commutativity of the matrix holds, right? Matrix property commutative property valid right? So in general, it's not valid. Commutative property does not hold for the matrix multiplication, but this is here under the inverse. When a particular matrix is multiplied by its own inverse, it's going to be equal I. So that is there, this commutative property holds. It doesn't matter A multiplied by A inverse or A inverse multiplied by A. So both will give you same answer, that is identity matrix. Right. So this is the definition. Right. Here is the definition. The inverse of A is A inverse only when the inverse of A is A inverse only when A multiplied by A inverse equal A inverse multiplied by A is equal I. මේ අවස්ථාව හරියන මේ අවස්ථාවේදීම පමණයි inverse එකක් තියෙන්නේ ඕනම matrix එක. So for any matrix, for any given matrix, right, A inverse will exist. For any given matrix, inverse will exist only if this property holds true, right? There are sometimes there is no inverse at all, right? There are some cases there are no inverse at all. So if I ask you, so can you name such situation where we cannot find an inverse, right? We know that in order to find an inverse is a square matrix. So can you please suggest me any occasion where you cannot find an inverse? So last week we discussed about this. Any occasion where you can't find an inverse? Yes. Yeah. I got a direct message saying when determinant equals 0, right? So yes, so you know that in order to find inverse, what we did, so we divide adjoint by its determinant. So when the determinant is equal 0, so that means the inverse is not defined, right? So for the matrices where the determinant is 0, we give a special name. What is that name? For the yes, what is? Sorry? I can't hear properly. Have to loud. Skew-symmetric matrix. Any other answers? Yes, the answer is singular matrix. Right? So when the determinant is 0, we call it as singular matrix. So you can remember like this. You know about in English you know about singularity and the plurality. Singular plural කියන එක මං හිතන්නේ ඔයගොල්ලෝ දන්නවා English වල. Right? If there is only one single thing, so we call it it's singular, and if we have multiple things, we call it as plural, right? Singular, plural කියන එක අහලා තියෙනවා, right? So in this case also you can remember like that if the matrix do not when the determinant is equal 0, so that means it does not have a determinant, then you can consider it as singular. Right? So when the determinant is 0, it is called as singular, and there at that situation we can't find it. Right. With that remembrance, why do we need an inverse? Right. So the next question, why we need it? So I am an inverse right? Because with matrices we don't divide. Seriously, there is no concept of dividing by a matrix, but we can multiply an inverse, so which achieve the same thing, right? So So in the matrix world, so in the previous slide also, I told you, right? Here, 1 divided by A, 1 divided, A is a matrix, so we usually not define it like this, 1 divided by A, because we don't divide by a matrix, right? What they are telling is, so why we need an inverse? Because with the matrices, we don't divide. ඔගොල්ලෝ matrix කියන දේත් එක්ක division is not possible. So normally in maths, what we are doing, so what are the main 4 functionalities? Right, addition, subtraction, multiplication, division. Like when we are talking about the numbers, always these 4 main operations are coming on, right? But so here also you have learned about the matrix addition, the matrix subtraction, matrix multiplication. But have you ever heard of matrix division? Right? So here you talk about matrix addition, subtraction, multiplication, but no division. So why? Because with matrices we don't divide. Matrices එක divide කරන්න division නෑ. Seriously, there is no concept of dividing by a matrix. Instead of that, අපි division එක වෙනුවට කතා කරන්නේ. So we can multiply by an inverse. But in actual sense, it is same thing as divide. But අපි divide කියන වචනේ භාවිතා කරන්නේ නැහැ සහ usually step එක කරන්නේ. Other than that, what we are doing is, again, we are multiplying by an inverse. So you know that multiplication is possible. So therefore, in order to symbolize the division, we use the multiply by an inverse. So actually, that is the reason why we need inverse in matrices. Right. Say we want to find x. Right. Say we want to find matrix x, and we know matrix A and B. Right. Say we want to find matrix X, we want to know matrix A and B. So let's consider like this. So you have a very simple equation. So this is the equation you have. So in order to find X, what will you do? In order to find X, what will you do? X
4 divided by 2.
4 divided by 2, right? So in order to subject X, X ukta karagana, api karane 4 divided by 2. So that is the thing that when we are doing, we normally doing when we have such case, actually in equation, right? So here also we need to subject X ukta karagana, right? We want to find X. Assume that we know A and B. So here, all these are matrices. So let's assume we know A, we know B, and we want to find X, right? So it would be nice to divide both sides by A. So maybe if we consider like this linear equation, so what we have to do is we need to divide both left and right from A matrix. X උක්ත කරගන්න නම් අපිට කරන්න තියෙන දෙපැත්තම A වලින් බෙදෙන එක. Right? But remember, we can't divide. In the matrix world, division is not possible. So then what we can do, right? So we know that we can't divide, but instead of the division, we can use multiply by the inverse. Right? So we can't divide, but we can do multiply by an inverse. Right? So that is what happened here. So here you can see, right? Here what they have done is, now you have been said that you can't divide. ඔයගොල්ලන්ට කියනවා බෙදන්නේ නැතුව මේ වැඩේ කරන්න. එහෙනම් මොකද කරේ? So then what happened? So here, then we multiplied by A inverse. This side also, we multiplied by A inverse. Let's assume both of these are I. Right? So here, instead of dividing, so it is already multiplied by A inverse. So here you will notice something, right? So here also you will notice something. So I should remind you that as well, right? Assume that here So let's say you know that now you can't divide. The only option you have is to multiply it by an inverse. Come option එක ඔයාට A inverse වලින් වැඩි කරන එක තමයි. දැන් මෙතන මෙහෙම දෙයක් වුණාද බලන්න. So on the left hand side I multiplied it by A inverse. Right? On the right hand side, so you may be wondering, why can't we place A inverse like this? So here A inverse is added at the end of XA. XA වලින් පස්සේ තමයි A inverse එක දාන්නේ. Here also they have added A inverse to the right hand side after B. So you may be wondering, ඉතින් අපිට මෙතන දාන්න තිබුණානේ. ඇයි B වලට පස්සේ දැම්මේ? Or else you may be wondering, so other than placing this A inverse here, මෙතනින් අයින් කළා, we can put here නේ. Anyone, can you say why is this? Anyone, please answer me, why is this? Yes, because of the commutative law, right? So here, so under the commutative law, you have learned that, right? You have learned that A, AB is not going to be equal, is not going to be equal BA. Right. So here actually, the thing is, it is important the place where you put the matrix. Ugolo multiply කරනවා නම්, you should preserve the order, right? You should preserve the order. So here you will see, so you have added the A inverse at the end of XA. ugolo XA වලින් පස්සේ A inverse එක දැම්මා නම්, on the right hand side also you have to place the A inverse after B. So here if you have put the A inverse on the beginning, right, then again you need to put the inverse at the beginning of B, right? That is mandatory. You need to keep in mind. So here, so it doesn't matter. So no need to always add A inverse at the end of XA. Saving A inverse what A inverse. So you can put in front of XA. So if you are going to put the A inverse in front of XA, then here also you should place A inverse in front of B. B වලින් ඉදිරියට A inverse කියන එක place කරන්න ඕන. Right. So that thing you need to keep in mind. Right. And we know A, so here, after you have, so you know that now the division is not possible. So therefore, the only option you have is to multiply it by A inverse. So here, after you have placed A inverse, so here what you have done, you have multiplied both left and the right hand side from the A inverse. දෙපැත්තම A inverse වලින් වැඩි කරා. So here A times A inverse, you know that it is I, and B times A inverse, it is B times A inverse as it is. And you know that, and again under the basic lecture we have learned that if any vector is multiplied by a unit vector, so the answer we get is the same vector as it is. ඕනම vector එකක් unit vector එකකින් ගුණ වුණොත් අපට එන්නේ ඒ vector එකම තමයි. So here all the expect is multiplied by a unit vector. So finally we got that vector itself. It's like in the number world, in the real number case, අපි ඕනම සංඛ්‍යාවක් එකෙන් වැඩි කරනවා වගේ. දෙක එකෙන් වැඩි වුණාම දෙකම තමයි. 100 එකෙන් වැඩි වුණාම 100ම තමයි. So although we have multiplied 100 by 1, it's 100. Although we multiplied 1000 by 1, it's 1000. So as in the real world case, real number case, right? So in the matrix world also, whenever you multiply any matrix with an identity matrix, so that is going to give you that matrix again. Right, inverse may not exist. right? The inverse may not exist. So this thing we have already discussed, but again, first of all, to have an inverse matrix, so first thing is, in order to calculate inverse matrix, it should be square. Number of rows and number of columns must be same, right? So that is the first thing. Again, I'm telling for the MCQs. So sometimes you will find whenever you finding referring to the references on the internet, or whenever you finding more questions from the internet, you will get questions to calculate the inverse. But actually, when you check the order of the matrix, it is not a square matrix. ලොකු matrices දෙනවා inverse හොයන අතරමඟදී තමයි සෑහෙන කාලයක් නාස්ති කරලා පස්සේ තමයි ඔයගොල්ලෝ identify කරන්නේ මේක square matrix එක නෙමෙයි කියලා. So that is must. So whenever you ask to find the determinant, whenever you ask to find the inverse, first thing is to check whether this particular matrix is a square matrix or not. So that's the first thing. But also the determinant cannot be zero. As we have already discussed, it should not be singular matrix. Right? There should be some value. It's not equal, zero value should be there for the determinant. Right? Okay, same thing. Right. So the bigger matrices, the inverse of 2 by 2 is easy. Again, right? Inverse of finding 2 by 2 is easy. Compared to larger matrices 3 by 3, 4 by 4, and etc. For those larger matrices, there are three main methods to work out the inverse. Right? Inverse of a matrix using elementary row operation, Gauss-Jordan. Inverse of matrix using minus, cofactors, and adjugate or adjoint. I use a computer or a calculator, right? So normally here we are going to use this particular method, minus, cofactors, and adjoint. So there is another method called elementary row operations, right? So after completing the matrix lectures, so I will be doing a short lecture on these elementary row operations, right? So using that method also, you will be able to find the inverse of a matrix if you have a higher order of matrix like 4 by 4, 5 by 5, and even for the 3 by 3. Right? Remember that this third method is not allowed for this course using a calculator, right? Right, again, same thing. So the summary of this slide, right? The summary of this slide is this one. So almost all the other things we have already discussed. Right? In order to find A inverse, first thing is you need to find adjoint A, and then you need to divide adjoint A by its determinant. So then only you will get the inverse of A. Right? Inverse of A can be found like that. Right. So here is an example to find A inverse. So now on, please find what is the inverse of the given matrix A. What is the inverse of given matrix A? Those who have found, you can send me the answer. Again, I have received one answer, expecting more answers to compare the result. Right. So, right, correct. So this is the answer, right? So this is the matrix. So in order to find the inverse, first thing you need to find that joint. So that means minus cofactors. And after converting the cofactors to adjoint by through transpose, you will find that joint. And then, so here the determinant is 1 and the adjoint A is this one. So then whenever the adjoint is divided by the determinant, so this is the inverse matrix. Right. Solution of simultaneous linear equations by determinants, Cramer's rule. This is again, I think, you know very well, right? You know very well under the basic maths course. So there, I think most of the times you have worked with the two simultaneous equations, but as far as I know, you have worked with the three simultaneous equations also, right? So the solutions of simultaneous linear equations by determinants, Cramer's rule. So here, if you look at the topic, so there are a few important points that you should need to think of. That is simultaneous equations, linear. This is very important, right? So you can apply this method only when you have linear set of equations. How do the degree cut, right? So when the degree of an equation is going to be 1, so that is we call it as the linear equation. Only if you have set up linear equations, you will be able to use Cramer's rule in order to find the unknown uh, constants or variable, whatever, right? So here solutions of Samagami Samikarana Visadi, right? So here three equations have been given, right? When the three equations have been given, so out of the coefficients of these equations, you can form the matrix by your own, right? Right. May coefficients color. So here A1, it's B1, it's C1, and also A1, B2, C2, then A3, B3, C3. Right? So using this 9 coefficients, right? No, 9 coefficients, you will be formulate this matrix called D, right? Matrix called D. Right. So then, right, matrix called D. Then you will using this particular matrix and also this D1, D2, D3, you will be able to find what is X, Y, and Z. So for this one, so the Y use Cramer's rule, you may be wondering rather than using a traditional method, why you are going for the Cramer's rule. Given a system of linear equations, Cramer's rule is a handy way to solve for just one of the variables without having to solve the whole system of equations. They don't usually teach Cramer's rule this way, but this is supposed to be the point of rule. Instead of solving the entire system of equation, you can use Cramer's to solve for just one simple variable, right? So this is one such situation, and the other one is, so the basically the first thing is why we use Cramer's rule is if we have more than 3 simultaneous equations to solve, so then it will be advisable to use Cramer's rule. So that is one thing. And the other thing is, most important thing is, if you just want to know either X or Y or Z, හිතන්න ඔයගොල්ලන්ට මේ XYZ කියන තුනම අවශ්‍ය නැහැ මේ එක component එකයි හොයන්න ඕනේ, right? In order to find, right, in some cases you have to find only one particular either it can be X or Y or Z. So then at that situation, this Kramer's rule, the method of Kramer's rule is advantageous. In the traditional method, right, if we are going to use traditional method in order to solve the set of simultaneous linear equations, what we are doing is, so we need to, so for example, we can take the first equation, we multiply it by a particular constant, and then add it to the second. Likewise, we need to, so most of the time when we are using the traditional method, one variable is depend on the other two, or else at least other one. එක variable එකක් හොයන්න අපි අඩු ගානේ අනිත් variables දෙක අනිවාර්යෙන් හොයාගත්ත යුතු වෙනවා. අඩුම ගානේ තව එකක් හරි හොයන්න ඕන. Right? In order to avoid that, so here under the Kramer's rule, if you need x, you need to only find x. What you can do, right? You can get the determinant of this particular if you want to find x, right? So then you have to consider only this calculation only. If you want to y only, you can consider this calculation only. If you want to consider find z only, you have to do this thing only. You do not need to find, let's assume you need to find z. So then you do not need to find x and y and then go to z. You can straight away find z. Right? So whenever you are undertaking the traditional method, you need to, most of the time, you have to find all the other rest of the variables in order to find the other variables. Dependency. Right? But in the Kramer's rule, it's not like that. You can find only the target variable, right? Only the target variable. So how to find actually? So under the Kramer's rule, we want to find four determinants. Determinants of four matrices, right? Determinant of four matrices, right? Famous rule like that. So if you are going to find almost all the variables, in set up three simultaneous equations, then you have to find four determinants. So what are the four determinants? Determinants are so the first thing is, so this is the matrix that you have constructed using the coefficients of these three simultaneous equations. The simultaneous equations වල coefficients වලින් හදාගත්ත original matrix එක තමයි මේ තියෙන්නේ. Right? So that thing you need to find out. Right? That thing you need to find out. So that particular original matrix, determinant of that particular original matrix is here. ඔගොල්ලෝ හදාගන්න original matrix එකේ determinant එක තමයි හැම වෙලාවෙම denominator එක විදියට යන්නේ. So as the numerator, how it differs? For the x, what is the numerator? For the y, what is the numerator? And for the z, what is the numerator? So when you compare with our original matrix here, what is the difference? So if it is x, if you want to find x, so here, instead of a1, a2, a3, this comes. Instead of, if you want to find y, instead of b1, b2, b3, so this should be in the middle, but instead of that, you have d1, d2, d3 at the middle. So if you want to find z, instead of c1, c2, c3, usually c1, c2, c3 is here, but instead of that, this comes. Right? This is the only change. Between x, y, and z. So that's why I told you, if first you need to find the determinant of this particular matrix, then you need to find the determinant of this one. This one is altogether 4. Right? So actually, I told you that when you're coming to the third year, you have a subject called Applied Numerical Methods. Right? There, as the questions, you will be given scenarios. So by reading the scenario, you are the one who need to create the set of simultaneous equations, right? Right? So if we consider about these questions, you have given the three simultaneous equations. What you have to do is, by considering the coefficients of these three simultaneous equations, you need to create this matrix. Out of this matrix, you are going to alter each column depending whether you want to select find x or y or z. x the y the z the කියන හොයන්න කියන එක අනුව මේ columns වෙනස් වෙන එකයි වෙන්නේ. But under that third year course, you will be given an explanation of a question. Scenario එකක් දෙන්නේ. ප්‍රශ්නේ මේකයි. So out of by reading the question, you are the one who should formulate these three simultaneous equations. ඔයාලට තමයි ප්‍රශ්නේ කියවලා මේ simultaneous equations 3 or 4 whatever you need to create by your own. Then you know, after creating this simultaneous equation set, you have to find out, you have to create this matrix. So after altering this matrix, right, you will be able to find x, y, and z. Remember that in those scenarios, you do not need to find all x and y and z. You maybe want to find either x or y or z. So there, in such cases, it is advantageous to use Kramer's rule. So therefore, basically, that is why Kramer's rule is somewhat popular, right? So there, in the third year course, you are allowed to use the computer and the calculators, right? So although you were given that permission there, so during this course, you are not given so by almost all the calculation. For example, in this case, almost all the 4 determinants has to be find out by yourself manually. And here, remember that, please read the question again carefully. In the question, either you may be asked to find x or y or z, or sometimes x and y, or y and z, right? ප්‍රශ්නේ පැහැදිලිව කියවන සමහර වෙලාවට අහලා තියෙන එක දෙයක් වෙන්න පුළුවන්. එක x විතරයි, එක y විතරයි. So students, what they are doing, ඊළඟ දාගෙන යන්නේ ඔක්කොම හොයන්න. Right, what they are doing, they are finding x, y, and z. So if question asks to find only x, right, then you have to find only 2 determinants. But if you are going to find all 3, then you need to find out all 4 determinants. So therefore, that's why please read the question carefully and understand what actually you have to do within the question. Right. This is the set of equations. Now, please solve the following system of equations using Kramer's rule. And sometimes when the question says solve the following set of equations using Kramer's rule, right, if I am specifically writing solve this set of equations using Kramer's rule, you can't use the traditional method to solve this. If you have used the traditional method to find the solutions to these equations, the marks will be given 0. Right? So therefore, it is important. So please solve the set of equations using Kramer's rule. After you find it, you can send me the answer. Those who have finished can send me the answer. So if you have received the answer, please send me the answer. It doesn't matter it is correct or wrong. So either if you have found X or Y, you can send me the answer. Seems that you are taking too much time. Anyone who has found X? Either X or Y or Z. Okay, what is the determinant of the original matrix? Consisted of the coefficients of this equation, three equations. I mean 5, 7, 1, 6, 8, 5 minus 7, 1, 6 minus 8 minus 1, 3, 2 minus 6. So what is the determinant of that matrix? 34. 34. Any other answers to this? Seventeen, 55. So okay, if that is the case, 55. More answers saying 55. So okay. So if that is the case, anyone who found X? Anyone who found X? Okay, anyway, since time is the problem, so I'm showing you yes true, right? Yes true. X is 1. Yes. Yes true. Right. So the original matrix, the determinant of the matrix is 55. 55. Right. Another thing, students, I'm saying is so if it is a 3 by 3 equation, right? If it is a 3 by 3 equation, if it is a 3 by 3 equation, so you know that now you have to find four determinants. Right? 3 by 3 equation එකක් නම් 3 simultaneous equation එකක් නම් ඔගොල්ලොන්ට determinants හතරක් හොයන්න, right? So the first thing, so sometimes your question asks to find just x or y or z, or so the question I may ask you to find almost all the variables x, y, and z. So there it is advisable you to first to please calculate first the d, right? First calculate this one, right? Sometimes you may start with D1, D2, D3, whenever, but although you are asked to find X only or Y only or Z only, you require this D. මොකක් හොයන්න කිව්වොත් ඔයගොල්ලන්ට මේ D ඕනේ. Right? තුනම හොයන්න කිව්වොත් එකක් හොයන්න කිව්වොත් D අවශ්‍යයි. So therefore, first, please calculate on D. Why is it? By any chance, if, right, හදිසියවත් මේ D හොයලා එක බිඳුව වුණොත්, if D becomes zero, right, if D becomes zero, can you proceed further to find XYZ? Can you proceed further to find XYZ? Yes or no? Yes or no? If this D becomes zero, can you proceed further? මේ D බිඳුව වුණොත් ඔයගොල්ලෝ ඉස්සරහට calculate කරන්න යන්න පුළුවන්ද බැරිද? Yes or no? No. So therefore, I have seen that some students, they have started calculating. First they find D1, D2, D3, and then find D. So what will happen if D? Therefore, so if you are asked to use the Cramer's rule, then you are, so I'm instructing you first to find D. If D becomes zero, you can stop at their stop that point. D බින්දුව වුණොත් එතනින්ම ඔයගොල්ලන්ට වැඩේ නතර කරන්න පුළුවන්. So otherwise you are finding D1, D2, D3, assume that they are not equal zero. But after you find all these three only, you are going to find D. මේ ඔක්කොම හොයලා අන්තිමට යනවා D හොයන්න, එතනදි බින්දුවයි. So then you have consumed lot of time. You have wasted lot of time. ඒ වෙද්දිත් ඔයාලකු කාලයක් නාස්ති කරලා ඉවරයි. So now by yourself you have understood how much it take time. Right? කොච්චර කාලයක් වැය වෙනවද මේ දේ කරන්න කියන එක ඔයගොල්ලෝ experience කළා දැන්. Right? You took a considerable amount of time. But so if you have initially find D and found that it is going to be equal to zero, then you can stop at that point. තව දුරටත් proceed කළා වැඩක් නැහැ. ඔයගොල්ලෝ එතරම් නතර වෙනවා. Why? Right? Why? Because in order to find X, Y, and Z, you need to divide each and every determinant by this D. This D. මේ D ම බිඳුව වුණොත් එතනින් එහාට proceed කරන්න බෑ අපිට ගන්න. So therefore, first find D. Then only you can continue to find D1, D2, D3 if D is not equal zero. If D is not a singular. Right? Right? So that is again one thing I'm reminding you. So likewise, so when you first find the D, that is going to be 55. And so as the answers, I got 17, 31, it doesn't matter. So you can get incorrect answers by calculation by yourself, and presenting the answers to me is very important. Right? Had the calculation errors, it doesn't matter. So try the question. And also, when I say that, please send me the answer, sending it's very good, right? But students, remember that this is a paper, right? This is a competition. So therefore, you need to be quick, and also you need to be accurate. You need to be accurate and fast. The two things must be assured when you are facing to the maths paper, right? It doesn't matter whether any maths paper, right? One maths paper, so you need to compete with time. Right? You need to compete with time. So whenever you are going to compete with time, you should maintain the accuracy as well. Right? So therefore, when you are doing these calculations, right, please be very careful. Right? And here, so you saw that, so X is D1 divided by D. So D is 55 and D1 is 55, D2 minus 55, D3 minus 55. So then X is going to be 1, D1 divided by D, Y is D2 divided by D, that is minus 1, and Z is D3 divided by D. There are students who has found all these three in time. Good. Right. So the others also, by looking at your friend's speed, friend's pace, you need to improve yourself, right? To solve the question fast and accurate. Right. So this is again another question, right? This is again another question. I'll show you the answers, right? This is the original D by looking at the selecting the coefficients of the three equations. So here the original matrix is formulated, and after finding the determinant of that matrix, you will be get the answer as 490, right? So then D1 answer is 1257, D2 1676, D3 2540, right? So whenever you divide it to find x, y, and z by D, you will get x equal 3, 4, and 6, right? So you can check by yourself. So this actually marks the end of that lecture, right? Which is the determinant part 2, right? Determinant part 2. So we have stopped where you know, so that is Kramer's rule actually. So now you know why specifically we go for the Kramer's rule. If you want to find only one variable, Kramer's rule is ideal. And also if you have more variables along with more simultaneous equations, so those type of situations also it is advantageous to use Kramer's rule rather than going for the traditional method. Right. Next, we will go for the other lecture since we have lecture number 4, right? So here we are going to look at consistency of systems of simultaneous homogeneous equations, right? Consistency of system of simultaneous homogeneous equations. So actually this is the topic I want to address first, right? Want to address, but in order to give you a basic foundation and remind you about the Kramer's rule, that's why I did the previous lecture. හරිනම් මම කලින් lecture එක කළ යුතු නැහැ. මොකද ඔයගොල්ලෝ basic maths වල කරපු දෙයක් නිසා. But so as a revision, I again go through the Kramer's rule and show you the importance of using the Kramer's rule, why we need Kramer's rule, and what are the occasions that we are going to use Kramer's rule when compared with the traditional method. And also, so what are the tricks when we need to be considered when we are using the Kramer's rule specifically? It's important to find the D first rather than going to find D1, D2, D3. So here also I'll show you why is it. Right. So here, so this is what you need to learn. Consistency of system of simultaneous homogeneous equations. So here you will learn about what do you mean by consistency, what do you mean by homogeneity, and how you are going to solve a system of simultaneous homogeneous equations. So this lecture is also based on the concept of determinant, right? The concept of determinant, we will see, right? Right. So, consistency of system of simultaneous homogeneous equations, right? So here again, you have been given 3 simultaneous equations with 9 coefficients. Coefficients, these one, A11, A12, A13, A21, A22, A23, A31, A32, A33. So by using these 9 coefficients, here we have constructed our original matrix D, right? D. So I told you, so in order to do this, first we need to be clear on these keywords. Keywords, homogeneous. What do you mean by homogeneous? Right? So, and also consistency. All these names, these are English words. English වචන. So these English words have different meaning according to the different context that they have been used. Right? මේවා ඉංග්‍රීසි වචන වුණාට එක එක context වලදී එක එක අවස්ථාවලදී එක එක විදියට තමයි මේවා meaning again. That, for example, if we just use these two words in our English essay or a literature poem or something, it has different meaning. But when it comes to the mathematics, what do you mean by consistency? What do you mean by homogeneity? So, for example, in physics, you are going to use in physics or in embedded systems, right? In microcontroller programming, in embedded systems, you are using homogeneous sensors and also the heterogeneous sensors, right? ඔගොල්ලෝ use කරනවා homogeneous sensors පාවිච්චි කරන heterogeneous sensors පාවිච්චි කරනවා. එතනදී, right there, what do you mean by homogeneous sensors and what do you mean by heterogeneous sensors? For example, if you are going to use same type of sensor, for example, let's say, right, you are going to build a waste belt for visually impaired people in order to identify or in order to detect obstacles. Okay, right? Visually impaired. Under connector, right? එයාගේ ඉස්සරහා තියෙන objects හඳුනා ගැනීම සඳහා ඔයගොල්ලෝ මොකක් හරි prototype එකක් design කරනවා. We'll say it's a waste belt, right? Sensor belt එකක් හදනවා. So there, in order to create this sensor belt, you are going to use, let's say we are going to use set of ultrasonic sensors, right? You will be using set of ultrasonic sensors, only ultrasonic sensors. So then that particular waste belt or sensor belt is built on set of homogeneous sensors. අපි කියන එකම ජාතිය sensors පාවිච්චි කරා නම් එම homogeneous sensors. So for example, assume that you are going to modify that particular waste belt or a sensor belt in order to, by including a sensor in order to identify objects. The objects කලින් අපි කරේ detect කරන එක විතරයි, then detect කරපු objects identify කරගන්නත් යනවා. Right? For that one, other than using ultrasonic sensor, you are going to embed a camera sensor, a vision sensor there. So then, for the sensor belt that you have developed, you have used heterogeneous sensors. What do you mean by heterogeneous sensors? Different types, sensors with different capabilities. So there you have used heterogeneous sensors. So likewise, then the embedded systems already homogeneous sensors, heterogeneous sensors can it? Either homogeneity can it, right? Right. Sometimes in English, right, we are calling about English or in climatic sciences, we call it as homogeneous climate, right? එකම වගේ තියෙන climate එක. So in maths, right, homogeneous equations. What do you mean by homogeneous equations? A polynomial is homogeneous if all its terms have the same degree. Now, what do you mean by a degree? Right, degree. So here you have three different, if you consider about one equation, right? If you consider about one equation, right, it has three variables, x, y, and z, right? X, y, and z. So almost all these variables you have when you consider about the power of these variables, that is one. So the degree is one. So therefore, this equation is considered as a homogeneous equation. Likewise, all the other two, the rest of the two sensors is also considered as homogeneous equations. Why? Because all terms have the same degree. Right? So the first keyword is clear for you, that is homogeneity. So what do you mean by homogeneous? The polynomials. So here we are using the polynomials which are having where all the terms have same degree, right? Again, this is a clarification on what you mean about the degree of a polynomial. Degree is a monomial with the greatest exponent, right? So here we can consider here 9 only. So actually this can be considered as what? So here we can consider it as 9x to the power 0. So what is x to the power 0? To the power 0 එකයි. right? X to the power 0 is going to be equal 1. So that is why here x to the power 0 is not indicated. Indicate. So, but however, the degree is 0. So here x plus 4, since the power of x is 1. Here x squared plus x plus minus 5. So there are the degrees too. So here we degree consider the highest power. Right. So here 2x cubed plus 11x squared. So here also the highest power is 3. And here uh, x to the power 2 times y to the power 3 plus 6x4 plus y1. So here look at. Now I'm going to term xy mixed term. So here in this particular term, both x and y are there. However, no matter whether it contains only x only or y only or x or y mix or xy z mix. So z but however, we consider about the degree. So if we consider about the degree, so it is going to be 5. So here 4. So when compared with 5 and 4, 5 is the greater. So therefore, the degree of this particular equation is 5. Right. Right. Now we are coming. Consistency of simultaneous homogeneous equations. So first, I'll again clarify, give explanation on what do you mean by consistent and what do you mean by inconsistent. What do you mean by consistent? What do you mean by inconsistent? Consistent is a system of equation is said to be consistent if they have one or more solution, right? If they have one or more solutions, so then we call it as consistent, right? උදාහරණයක් විදිහට බලන්න මේ පළවෙනි සමීකරණ දෙක. So let's consider about these two equations, right? X plus 2y equal 4, 3x plus 2y equals 2. So now students tell me what is x and what is y. X key the y key. What is x and what is y? Here. What is x and what is y? So quickly, please solve this. You do not need to use any Cramer's rule or anything. Just solve using the traditional method. Just solve and tell me what is x and what is y. Send me the answers. X equal 2, then y. Y equals 1. Any other answers? Any other different answer? Is x equal to? X සමානයි දෙකද? Any other answer? One is saying x equal to and y is equal 1. එක හරිද? X is equal minus 1. Then what is y? X is equal minus 1. Then what is y? Y is equal 2.5. 5 divided by 2. Okay. X is equal minus 1. Y is equal 2.5. Right. So So that is for these two equations. Now students tell me for this particular two equation, x plus 2y is equal 4 and 3x plus 6y is equal 12. So here what is x and what is y? So these two equations, what is x and what is y? උත්තර ඕන. x කීයද y කීයද? උත්තර නැද්ද? So I'm asking you what is x and what is y. So here you told me x is minus 1 and y is 2.5. So then what is this? So if you are not going to give me the answers, I will ask from someone else here. Hasari, what is x and what is y? Hello, Hasari, can you hear me?
Yes, madam.
What is x and what is y? ප්‍රශ්නේ කියන්න. හෙව්වනම් උත්තරේ කියන්න, හොයන්න බැරි නම් හේතුව කියන්න. Anyone, not only Hasari, anyone. කාට වුණත් එහෙමයි. What is x and what is y? Anyone please give me answer. උත්තර දෙන්න කවුරු හරි.
දෙකම සමාන්තරයින්ද ඒ දෙක ක්‍රොස් වෙන්නේ නැහැ.
දෙකම සමාන්තරයි. සමාන්තරයිද දෙකම සමානයිද? සමාන්තර කියලා දෙයක් නැහැ නේද? Right, these two are equations. These are not parallel. සමාන්තර නම් අපිට මෙතන මේ සරල රේඛාව අඳින්න ඕනේ. Right? අදහස් කරේ සමාන්තර කියන දේ නෙමෙයි මම දන්නවා අදහස් කරේ සමානයි කියලා. Right? So when you look at these two equations, you will identify that first thing is x plus 2y equals 4. So the second equation is 3x plus 6y equal 12. So if you divide this second equation by 3, right? If you divide the second equation by 3, you will understand, again you will get the first equation. දෙවෙනි සමීකරණයක් දෙකෙන් බෙදුවම තුනෙන් බෙදුවම ආයෙන්නේ පළවෙනි සමීකරණෙම තමයි. So but the problem is you have two unknowns. So anyway, so in this particular equation දෙකෙන් එකම කියවෙන්නේ. So but in this particular equation you have two unknowns but you have only one equation. Okay, ප්‍රශ්නේ. Right? You have only one equation in order to solve this two unknowns. So is it possible? Right? If you have two unknowns, but if you have only one equation, are you able to solve the equation? It's possible or not? Yes or no? Yes or no?
No, ma'am.
Huh? No. Why? Right? So here you understood that here. Here you have two unknowns. නොදන්න පද දෙකක් තියෙනවා but සමීකරණ දෙකක් තිබුණා. Right? Here you have two unknowns but you have two equations here. By solving these two equations, you will be able to find what is x and what is y. Right? That is the way. Right? ඔයගොල්ලන්ට නොදන්න පද ගන්නට සමීකරණ තියෙන්න ඕනේ ඒ වන්ස දාන්න. Normally, usually. But here the problem is, so now look at what they have indicated here. And බලන්න මෙතන they have. So after these two equations, they are saying unique solution. That means these two equations has unique solution. What is the unique solution of these two equations? What is the unique solution of these two equations? Go. What is the unique solution of these two equations?
Plus 2y.
Unique solution එක කියලා කියන්නේ ළමයි මේ සමීකරණ දෙක විසඳුවම එක තනි උත්තරයක් තියෙනවා කියන එක. ඒ උත්තරේ තමයි මේ උඩ ලියලා තියෙන්නේ. Right? Unique solution means when you solve these two equations, you have only one answer. What is that answer? X වලට එක උත්තරයකුයි y වලට එක උත්තරයකුයි තියෙනවා. X is equal -1 and y equal 2.5. So that is the unique solution, unique answer when you solve these two simultaneous equations. That is meant by unique solution. Right? But look at these two equations. May equations දෙක යට තියෙන්නේ මොකද්ද? Infinite solutions. What do you mean by infinite? What do you mean by infinite? In සිංහල අපි කියන අනන්තය. මෙතන කියන්නේ දැන් මෙතන කියන්නේ unique solution. ඒ කියන්නේ එකම එක උත්තරයයි තියෙන්නේ මේක විසඳුවම. ඒ උත්තරේ තමයි x සමානයි ඍණ 1යි y සමානයි 2.5යි. But when you solve these two equations, කියන infinite many solutions තියෙනවා. ඒ කියන්නේ solutions මේකට අනන්ත ගානක් තියෙනවා. Right? When you solve these two equations, they are saying these two equations have infinitely many solutions, infinite number of solutions. Oh, they have many. Anyone? They're going to penuate around. So when you look at this, you have only one equation, but with the two unknown variables. But here they are saying you have infinite many solutions. Penumata na ඕගොල්ලෝගේ පෙනුමට ඕගොල්ලෝ නම් මෙතන එක උත්තරයක් වත්ද? But they are saying infinite number of solutions. Anyone can say how this happened. Anyone? Is there anyone who can show us how this have infinite number of solutions? කාටවත් පේන්නේ නැද්ද මෙතන infinite number of solutions තියෙනවා කියලා? කෙනෙක් ඉන්නවා නම් කියන්න. පේන්නේ නැහැ වගේ කාටවත්. කාටම හරි පේනවා නම් කියන්න. If anyone can see, please explain us. Either in English or Sinhala. නැද්ද? Or else you can put a chat message explaining how it happens. Never. Right. Okay, I will. Oh, okay.
You can use any possible number.
No, I can't hear properly. No,
we can use any possible number.
Well, I think he's saying, right, look at this. If you put 1 to x, right, 1 plus 2 times, right, 2 times. So in order to make it 4, right, in order to make it 4, let's put -1. 2 times what? Or let's say -2. What is the answer here? What is the answer here?
Oh.
So එතකොට මෙතනදී මම ගත්තේ x සමානයි ඍණ 2යි. y සමානයි 3යි. So I'm putting x equals 0 plus 2 times y equals 2. දැන් උත් 4 ආව නේද? එතකොට මෙතනදී මොකද උනේ? x සමානයි x equals 0 and y equals. So I'm putting x equal 4 plus 2 times. So what is the answer? Again 4. So here x equal 4, y is equal. So likewise, how many values that we can get x and how many values that we can get y? මේ වගේ අපිට xy combinations කීයක් හදාගන්න පුළුවන් වෙන්නේ? Infinity. So here I have included only whole numbers. පූර්ණ සංඛ්‍යා විතරයි. මෙතන දශම සංඛ්‍යා වලින් දාලා හදන්න පුළුවන්. ඍණ ධන including minus, negative numbers, positive numbers, fractional numbers, rational numbers. In order to make it 4, in order to make right hand side 4, දකුණු පැත්ත 4 හදාගන්න මට ඕන combination එක x y ට දාන්න පුළුවන්. So that means I am having, for x and y, I am having infinite number of solutions here. So here, here only you have x equals -1 and y equals 2.5. But here you have infinite number of solutions, right? So that is the difference. Okay. So that is for the consistent. So if you are saying a system of equation is said to be consistent if they have one or more solution. අපි කියනවා නම් අපිට දීලා තියෙන equation set එක. So for the system of equations that we have given, in order to be consistent, either it can have a unique solution or either it can have infinite many solutions. Unique solution, unique කියන්නේ එකම එක solution එකයි, it can have 2 solution, 3 solution or up to infinite number of solutions. මෙහෙම වෙන ඕනම අවස්ථාවක අපි කියනවා system of equation consistent. Right. So then what do you mean by inconsistent? If a system of equation has no solution, it is said to be inconsistent. Solution එකක් නැති වෙන අවස්ථාව. Right. Now again, tell me, so solve these two equations. Right. Solve these two equations. Solve these two equations and tell me what is x and what is y. Solve these two equations and tell me what is x and what is y. No solution. No solution can be. Right. Same example, right? Within the x plus 2y equal 4. No possible solutions, right? X plus 2y equal 4. Within x plus 2y equal 4. So within 3x plus 6y equal 5. Make a. So if we divide by the whole equation by 3, right? So if we divide the whole equation by 3, what will happen? X plus 2y is going to be equal 5 divided by 3. So now look at, this is the equation that they have given, the first equation, right? This is the second equation which we have built by ourselves. Right now, if you compare these two equations, right? If you compare these two equations, what can you say about the left-hand side of the two equations? What can you say about the left-hand side of the two equations? They are equal. දෙකේම තියෙන x ධන 2y. So in both cases, left-hand side is x plus 2y. But look at the right-hand side. So x plus 2y is equal 4. X plus 2y is equal 5 divided by 3. එකක් කියනවා x ධන 2y සමානයි 4යිලු. Sorry. අනිත් එක කියන x ධන 2y සමානයි 5 බෙදීම 3යිලු. So is it possible? එහෙම වෙන්න බෑනේ නේද? Right? So therefore, in these type of situations, right, this system of equation has no solution. Right? But right, although I explain like this, ගොඩාක් students මෙන්න මේ අවස්ථාව. Right? Most of the students, this thing, that means infinite number of solutions with හිතන්නේ ඒගොල්ලෝ inconsistent කියලා. Wrong, totally wrong. මේ දෙක දෙකක්. These two are two different scenarios. Here, it has infinite number of solutions. But here, no solution. No solution වෙලාවේදී විතරයි අපි inconsistency කතා කරන්නේ. Right? So if it is consistent, it can have either unique solution or one or two solutions or infinite number of solutions. But if it is not consistent or inconsistent, there is no solution. මේ තුන හරියට clearly identify කරගන්න. It is important. Right? So not only for this lecture, but hereafter. Right? So now what is the difference between consistency and inconsistency? So this thing, right? So if you look at the topic, you know what you mean by consistency and inconsistency, and you know the keyword homogeneity. Right? Homogeneous means this concept. I make a concept. A polynomial is homogeneous if all its terms have the same degree. So by clearing out the meaning of the consistency and homogeneity, we were going to find consistency of system of simultaneous homogeneous equations, not today, but next week. අද කරන්න හැමම මොකද මේක දිගටම ගෙනියන්න ඕනේ මේක. Right? There should be a continuity in this case, in this lecture. So therefore, by just mentioning you, clearing you about these two keywords, consistency and homogeneity, we will continue the lecture on next week, right? So thank you for joining with the lecture. So here onwards, you can send me the messages for the attendance. Remember that tomorrow morning, you will be having the programming lecture. So thank you. Thank you.